the product and quotient rules. We'll start with the product. So if we have a product of functions, the derivative with respect to x of that product is the first factor times the derivative of the second factor plus product plus the second factor times the derivative of the first factor. Now you will note that the derivative of a product is not the product of the derivatives. Okay, so again, when we have a product of functions, the derivative of that product is the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. Also, another way to think of this is if we're looking at f times g, the derivative of f times g, you could write it as f prime g plus fg prime. There's a reason coming up that makes it nice to learn it in that order as opposed to fg prime plus f prime g, but either order is fine because it does not matter when you multiply what the order is that you're multiplying. My preference is going to be this one here because of what's coming up. Now, a couple of examples. Find the derivatives. Notice that I have f of x is gx squared plus 2 times 5x cubed minus 6x. Now, I've got to rename these. I can't call these function f and g like I did up there because the name of my entire function is f. So why don't we call this g and h? So if I'm looking at the product of g times h, we always want to write this out first, gh prime plus hg prime. And now we can say g, which is 3x squared plus 2, times, I'm going to take the derivative of h, that's what this notation means, plus h times, I'm going to take the derivative of g. Now we can see that h prime would be 15x squared minus 6, and g prime would be 6x. Now, from here, you have aloha, a lot of horrible algebra. So we would want to distribute this pair of factors. So I would get 45x to the fourth, and then I would get minus 18 plus 30, which is 12x squared, and minus 12. Over here, I'm going to distribute the 6x across this, which gives me 30x to the fourth minus 36x squared, and then we want to add similar terms. Now, if I were going to be perfectly honest with you, this is not the easiest way to do this problem. There is an easy way. The easy way is simply to, first of all, FOIL function f, and then take the derivative term by term of each one of these terms. Now, which would I do? Of course, I would do it the easy way. But I wanted to illustrate how to use the product rule. All right, let us look at another product. Y equals x cubed times the sine of x. Well, I can let this be function f and this be function g. And so I know that it is x cubed times the derivative of sine plus product rule plus sine times the derivative of x cubed. All right, well, the derivative of sine, we need to know what that is, and we know that from a previous section is cosine. So x cubed times the cosine of x plus sine times the derivative of x cubed. And really, that is all you can do. We do want to write y prime equals that. If you went with my preferred method of f prime g plus fg prime, again, I can still list it. It is the same thing. It does not matter what our order is. All right, our final product rule example is y equals 3x times the sine of x minus 4 cosine x. Now, this is easy because this is just a constant multiple. This is the product of 3x times sine of x. So this one's a little easier. This one requires some work. So just by using my notation that's going to indicate what I'm going to do. Dealing with the product piece, 3x times I've got to find the derivative of sine plus sine of x times the derivative of 3x. That is just the product rule part of this problem. Minus 4 times, and I've got to find the derivative of cosine of x. So we have 3x times cosine of x, that's the derivative of sine, plus sine of x times 3. I want to be very careful about this because this does not become 3x. It's 3 sine x. Minus 4 times, and the derivative of cosine is a negative sign. Now, this is where I want to give you a kill me now. Parentheses matter. Negative 4 minus sine x is very different from negative 4 times negative sine of x. So be careful with that. So just cleaning this up, I have 3x times the cosine of x, plus bring that 3 down in front, 3 times sine of x, and this minus minus becomes a plus. Notice that I do have some terms that can be added together, and so our final answer is y prime is 3x cosine x plus 7 sine of x. Now we'll move on to the quotient rule. The quotient rule gets its basis from the product rule. We're going to consider the following case. Consider cap f of x to be little f of x over little g of x. Now, in a little while, we'll come back and call this a high and a low. You'll see why in a little while. But let's just look at cap f of x equals little f x over little g of x, and we're going to find f prime in terms of little f and little g. Now, the thing is, all we know from the previous part of the lesson was product rule, and we do not have a product. So since we only know product rule, let us change this equation to one where we have a product. So big F of x times g of x equals little f of x. Now we're ready to use our product rule. F times g prime plus g times f prime of x equals little f prime of x. I took the derivative of the whole equation. Now we want to solve for cap f prime of x. So if we think about our algebra, all we've got to do is subtract big fx times g prime of x, move it over here, and then divide by g of x. So there's our subtraction step, and there's our division step. But it says in our instructions to find f prime of x in terms of f and g, not in terms of little f, little g, and big F. But we know what big F is. Big F is little f over little g. So I'm going to make that substitution. Now this is a compound fraction because we have a fraction in the fraction. And how can we make this better? We can make this look better by multiplying both the numerator and the denominator by g of x. If we multiply by g of x, distribute g of x across the numerator, I get f prime of x times g of x minus, and when I distribute g of x across this, the g of x's cancel. But look what happens on bottom. I have g of x times g of x, which is g of x squared. And we have actually just derived the quotient rule. So if I have f over g, then the derivative with respect to x of f over g is f prime g minus f g prime over g squared. So going back to thinking about my quotient as a function that's on top, so high, over the function that's on bottom, or low, we have low d high minus high d low over low low. That's the low function times the derivative of the high function minus the high function times the derivative of the low function over the low function squared. Or Santa Claus's version would be ho-de high minus hi-de ho over ho-ho. La la. All right, let's use that rule. Here we go. Here we have x to the fourth minus 6x squared over x cubed plus 5. This is my low function. This is my high function. Low times the derivative of high, I've gone ahead and taken the derivative of it, minus the high function times the derivative of the low function over low, low. Now we have a low ha. And let's remember, all of this is following a negative sign. Here we go. If I FOIL this, we get 4x to the sixth minus 12x fourth plus 20x third minus 60x. Now that's that part. Here we're going to distribute a 3x squared over this, leaving it all behind the negative sign. And when we distribute the negative across, we get negative 3x to the sixth plus 18x to the fourth. And we can combine similar terms, and we get this as our derivative. X to the sixth plus 6x to the fourth plus 20x cubed minus 60x all over x cubed plus 5 to the second power. Leave that factored. Don't multiply this out. All right, pause the video and write all that down. Our next example, y is cosine of x over sine of x. Again, low d high minus high d low over low, low. So that's sine x. Derivative of cosine is negative sine x minus cosine x times derivative of sine is cosine x all over sine of x quantity squared. And when we square a trig function, we typically write it like this with a sine squared of x. Now we want to do some work here. Notice that this positive times this negative gives me negative sine x squared, and then minus cosine x squared all over sine squared. Notice that if we factor a negative 1 out of here, we get negative 1 times sine squared of x plus cosine squared of x, which is a Pythagorean identity. And we know that that is 1. So I now have a negative 1 over sine squared x, and guess what that is? Negative cosecant squared of x. That is our derivative. Y prime is negative cosecant squared of x. If we go back to the problem, notice that cosine of x over sine of x is actually cotangent of x. So what we just did was found that the derivative with respect to x of cotangent of x is actually negative cosecant squared of x. That is pretty cool. Now, number 6, example 6, we're going to use quotient rule. It says do this one 2 different ways, constant times a multiple and quotient rule. The easy way is constant times a multiple. Recognizing that, we actually have 1/7 times x minus 3. So I can take 1/7 times the derivative of x minus 3, which is 1/7 times 1. So y prime is 1/7. Nice and easy. Now the other way would be to use our quotient rule. So our quotient rule would be low times the derivative of the top, which is 1, minus the top times the derivative of our denominator, which is a constant. So derivative of constant is 0 over low, low, 7 squared. So f prime g minus fg prime over g squared. And we can see that this will cancel out. We get 7 over 7 squared, which still is 1/7. When we look at the last example on this page, obviously the easy thing to do is to FOIL that function and then take the derivative. Pause this and write down what you see. On the final page, we see derivatives of trigonometric functions. You have to know these. Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant of x times tangent of x, and derivative of cosecant is the negative of cosecant times cotangent of x. Notice that the derivative of tangent is secant squared. This is going to always be non-negative. So that should tell us that tangent function is always increasing, which we know it is. The derivative of cotangent is negative cosecant squared. This will always be not positive. It will be negative. So cotangent should always be decreasing. So it's kind of neat. I have some little memory techniques here. The derivative of tangent is secant squared. I'll call it sexy, sexy. The derivative of secant is sexy tan. Just a stupid little memory device. Also, you need to know Your higher order derivatives, this is the first derivative, how we write it. Second derivative, y double prime, d squared y over dx squared. Okay. Third derivative, d cubed y over dx cubed. Very important to know that notation. And now the last example that we're going to look at is this one. Given f of x is 5x to the fourth minus 3x squared plus 2x minus 1, we're going to find the first, second, third, fourth, and fifth derivative. All right, first derivative, piece of cake. Second derivative is derivative of the first. Third derivative is the derivative of the second. Fourth derivative is derivative of the third. Fifth derivative, derivative of a constant is 0. Very nice. Let us remember acceleration is the derivative of velocity, and velocity is the derivative of position. So we now know that acceleration is the first derivative of the velocity function and the second derivative of the position function. Be sure to be able to show these relationships. Your TPs are for the product rule, problems 1, 5, and 13. For the quotient rule, problems 7, 11, and 15. See you next time.